All right, ladies and gentlemen, this is the second half of learning to find the key features of a graph from Vertex form. This is a refresher. If you remember the transformation rules that we learned earlier in the year, then this will fall in line exactly with what you learned in our first unit. So we're going to be paying attention to how looking at a formula for a quadratic in vertex form will allow us to determine whether or not it moves left, right, up, down, whether it reflects over the x-axis, or whether it will stretch or compress. So let's go ahead and try that with one. One of the things that's different, however, about these transformation rules is that we're simply going to be applying these transformation rules to quadratics, not any other kind of functions. So here this says a parent function is just some general f of x. We always know that we're going to be dealing with x squared if it's a quadratic function. So here are the steps that you may remember. I want to point out down here at the bottom that when we have a value that is in front of the quadratic that's a whole number, then that means that the parabola or the curve will stretch vertically or get narrower. And whenever it is a fraction like this in front of the quadratic, then it's going to shrink vertically, or it's going to compress or smush, making it get wider. All right, the only kind of reflection we're going to see is going to be this one right here, where we have the negative value on the outside. So we may have a we will have parabolas that reflect over the x-axis, but we won't have this kind. All right, let's try a little bit. So here's our table. If this is the form of the quadratic equation, then the value for a is simply going to be a positive 1 in this case, let's say. And if it was, then it would open upward because it's positive. The vertex would be h comma k, and the axis of symmetry would be the h value. The transformations would be that this would be a side-to-side transformation as listed right here. So if we're going to subtract a value, then we'll move to the right 8 units. So that's why we've said here that we're moving to the right 8 units. Then if we have something added to the outside of the squared term, then that's going to be an up and down transformation. So here, if we're adding it, then that means we're going to move up k units. So you may want to pull this out of your notes or keep this handy or summarize a few of these things right here in your current notes to make sure that you can handle these correctly. All right, so here's an example of an equation that is in vertex form. So we can tell from this that we have x minus 2 squared plus 3. So let's look first at what our a value is. Our a value is a negative 1. So that means that this is going to it's going to frown. It's going to point downward. The x value of the vertex is going to be positive 2, and the y value of the vertex will be positive 3. So here's our vertex. Then the axis of symmetry is just going to be x equal to the x value of the vertex. And the transformations indicate that we're going to move the parabola right 2 units and up 3. So a parabola that was sitting right here would move right 2 units, up 3, and we have one more transformation because it's going to flip. It's going to turn into a frown. So we have a third transformation that's not listed there. It's listed on this one, flipped horizontally or frowned. All right, so on the next one, y equals x plus 4 squared plus 1. Notice we have an a equals 1 here, so that means that we're going to have a parabola that opens up. When there's no negative in front, then it opens upward. It doesn't flip, because remember, a negative or a positive in front will flip this. A negative will flip it. So if it's a positive number, then we know we have a smiling parabola. It opens upward. Notice here that this pattern says x minus h. Well, we have x plus 4, so that means that we need to extract a negative 4 from this in order to satisfy this minus h pattern. So x minus h in this case would be x minus negative 4. So that's why we pull out a negative 4 for that h term in the vertex. And then the k value will simply be a positive 1. The axis of symmetry will be a negative 4. And the only transformations we have are that this will move to the left 4 units and up 1. All right. Here's a value here's a place where we have an a value in front that is not a 1. So we have a negative 2. So that means that if we have a negative 2, then we have two things that are going to happen. This is going to open down, or it's going to frown because the value is negative. Again, we have a pattern here. We have plus 6 when our pattern in the equation says a minus h. So in order to satisfy the pattern, in order to get a plus 6, we have to think of this in terms of x minus negative 6. So that's how we pull out a negative 6 here. And then since this is a plus k, then this will be our negative 5 because we are not adding 5, but we're subtracting 5. So our vertex in this is going to be negative 6, negative 5. The axis of symmetry, again, is equal to the x term of the vertex. The transformations on this one, there are 4. This will move left 6. It will move down 5. It will get narrower because of the 2 value, and it will be flipped horizontally, or it will frown. So it will look like it looks in this image. Let's think about one other thing when we look through these. Oh goodness, we had one more. I apologize. We had one more. So here's one where we have an a value of 1/4. So an a value of 1/4, it's positive, so it will still be a smiling shape. It will open upward. It follows the pattern of minus h, so we're going to pull a positive h out. So that means that we will have the vertex 3, negative 1, and an axis of symmetry of positive 3. We're going to have 3 transformations in this one. It's going to move to the right 3 units. It will move down 1 unit, and it will get wider because of this 1/4 value. So this is what it looks like. Here's our vertex. Then in this one, the vertex is here, the vertex is here, and the vertex is there. So let's think a little bit about what that means. Let's look back up in here. This vertex is right here at the top, and it is the maximum value in this parabola that opens down. So we're going to indicate that this vertex is a maximum value. Here we have another case where the vertex is a maximum value. These both open down. So always when the parabolas open down, then the vertex is a relative maximum. In this example, where the vertex opens up, then, where the parabola opens up, then the vertex is a relative minimum. Here's another one where the parabola is smiling, it's opening up, so the vertex will also be another relative minimum for this one. All right, so hopefully when you get a chance to practice some of this, then some of these transformations for quadratics will start coming back to you. So here's a quick review of what we talked about. These are the things that you saw on the last presentation. I won't go over that, but the transformation summary listed right here that goes with this equation, this may be helpful. You might choose to use the original, let me show you this. You might choose to use this original graphic that describes what happens with transformations, or you may instead choose to use this summary of how the transformations move. The parabola is going to move h units horizontally based on this, and you have to decide if it's left or right based on what you see about this pattern. Then it will move k units vertically. It'll move, if it's a positive k, it will move up. If it's a negative k, it will move down. Here, when it's a negative h, it will move to the right. If it's a positive k, it will move to the left. If the a value in front is a negative, then this will flip horizontally, or it will turn into kind of a frowning shape. If the absolute value of a here is greater than 0, in other words, if it's a number that's wait a minute, that's not right. This should be a 1. If it's greater than 1, then it will be narrower. And if it's smaller than 1, it will be wider. So this should be a 1 here. I apologize for that. All right, so here are the things you need to this is a resource you can use, recalling that this should be a reference to a 1 right here. Otherwise, you're ready to get started on some practice.